Hello, folks. How are you doing? I hope you're doing great. My name is Leonardo Figueiredo. Be welcome. Today, we will continue this module and keep advancing through the course. So, come with us that we teach you. And let's start sharing the screen. The magnetic circuit breaker, the strong variation of intensity of current flowing through the coils produces a strong variation of the magnetic field. The field created thereby triggers the movement of an iron core that will mechanically open the circuit and thus protect the source and part of the electrical installation, including electrical conductors between source and short circuit. The switching is instantaneous in the case of a rapid coil or controlled by a fluid in the case of a coil, which allows controlled firing. Generally, a switch is associated with high quality design to make thousands of maneuvers. The magnetic protection has a main purpose to protect the equipment against defects such as overloads, short circuits, and other faults. It is usually chosen in cases where there is a concern to protect the equipment with high accuracy. The thermomagnetic brakes. It's widely used in residential and commercial electrical facilities. This type of breaker has three functions. First, the maneuver, voluntarily opening or closing the circuit. Protection against short circuit. This function is performed by magnetic actuator, just like a solenoid, which makes the circuit breaker open because of the instantaneous increase of the current in the protected circuit. Overload protection. This is performed through a bimetallic actuator, which is sensitive to heat and makes the circuit breaker open when current remains for a certain period above the nominal current of circuit breaker, the adjustable current. And the circuit breaking tripping characteristics are provided by manufacturers through two main information, the nominal current and tripping curve. Other features are important for the installation project, such as nominal voltage, maximum current of the circuit breaker, and number of poles, single, double, or triple. High voltage circuit breakers. For the interruption of high current, especially the presence of inductive circuits, special mechanisms are required for the interruption of electric arc, resulting in the opening of the poles. For high power applications, the short circuit current can reach the values of 100 kiloamps. After interruption of the circuit breaker, must isolate and resist systems stresses. And finally, the circuit breaker should act when recommended that there must be a high degree reliability. Some types of high voltage circuit breakers: high volume of oil breaker, low volume of oil breaker, compressed air circuit breaker, vacuum circuit breaker, and sulfur hexafluoride circuit breaker, the SF6 type. And right here we can observe one circuit breaker scheme with the nominal current, the interrupting capacity, the selectivity class, sensibility, normal voltage, the brand, product line, alternating current symbol right here, and rating of the switch, the on-off. Inside we have the terminal, the stationary contact, the switch to power it on and power it off and rearm, the catch, the electromagnet inside, and the thermal part for the bimetallic part. And right here we have a moving contact. Comparison between fuses and circuit breakers. Circuit breakers are more used and with more resources than fuses devices with regard to overcurrent protection. Circuit breakers operate through separate relays, mainly high voltage relays, or series triggers. Its operation is repetitive, that they can be reconnected after they have acted, without the need for replacement. They are rearmable. On the other hand, circuit breakers are in most cases, multipolar devices, which avoid, for example, an undue single-phase operation, such as that which can occur with the burning of a single fuse of a three-phase device protecting the circuit from an engine, for example. The time current feature of fuses is not adjustable and can only be altered by a fuse change, by a different type and rated current. Note that fuses may become defective by changing their characteristics under the action of currents close to melting chain, and thus other subsequent currents lower than the nominal can cause the burning and interrupt the circuit. In the case of circuit breakers, the time current characteristics, in addition to being adjustable in some cases, is not affected by currents close to that would trigger the shot. So right here we have advantages and disadvantages of each one of them in the comparison. Performance characteristic in the short circuit. The fuse, it does not need a detailed calculation of a short circuit current. For the circuit breakers, it needs a detailed calculation of short circuit current, including the curve analysis. Fuse, high breaking capacity, and for the circuit breaker, varied breaking capacity. So we have a huge range of applications. For the fuses, high limitation. For the circuit breakers, limitation in high breaking capacity. For the fuse, optimization of the interruption time. And for the circuit breaker, varied interruption time. Fuse, easy availability. And for circuit breakers, availability with restrictions. For the fuse, low cost, most of times. And for the circuit breakers, it depends, varied cost. Residual current devices, RCDs. According to the data from Abracopel, Brazilian Association of Awareness of the Dangers of Electricity, in 2011 in Brazil, there were 298 deaths caused by electric shocks. In addition to 265 fires have electricity as a probable cause. Most of these accidents could be avoided by adopting a simple device that is called the RCD. According to these statistics, we have number of deaths according to the local. So the air net, the aerial net, the industry 9%, and houses 27%, almost 28%. The domestic part, the industrial part, and the supply part. Well, guys, this is the end of the video, but the module is not over yet. Please stay with us, that I'll meet you in the next video to continue this module. Keep watching and keep training. See you later.